Hi guys, welcome back to the session. This is the very first introduction video of our new minor project which we are going to build using Java language, and the name of the project is Compressor and Decompressor. So we are going to build the series of this whole project, Compressor and Decompressor, and in the upcoming videos we are going to talk a lot around this project, and we are going to code it out, and we are going to make sure that everything works fine related to this particular project, Compressor and Decompressor. This is the very first introduction video, so let's discuss all about what do we mean by compressor and decompressor. We'll also have a quick live, uh, I would say, a live tour of the project, that how our project is going to look like, and we are going to discuss a few things around compressor and decompressor again. Okay, so let's start. First, let's understand these two terms, compressor and decompressor. Okay, what do we mean by these two terms? Okay, compressor basically means data compression. Okay, data compression. Okay, now what do I again mean by data compression? Data compression is basically a technique. Okay, it is basically a technique which helps in reduction in the number of bits, reduction in the number of bits which are used to represent the data, which are used to represent, which are needed to represent a data, right? Data consists the combination of bits, and if we somehow make sure, if we somehow evaluate how we can reduce the number of bits which are used to represent that particular specific data, we can call that process as data compression. Okay. Now, if while while reducing the number of bits, if we are losing the data, if we are losing the data, that will be a lossy conversion. So of course very much obvious it is that we going to make sure that we don't get trapped in this lossy conversion. We're going to make sure that we have a lossless conversion. Lossless conversion, this is a very major highlight of our project, that while reducing the number of bits, while compressing the data, while compressing the file, while compressing the image, we're going to make sure that it is a lossless conversion. Okay, compression के what are the advantages, what are the advantages of compression? ठीक है, now we are going to compress a data. ठीक है, we're going to reduce the size of the data. ठीक है, now what all are the benefits, why we need compression, right? So first and foremost benefit, can save storage, can save storage. Let's say I had a file which was taking 20 MBs, just giving a very short example, which was taking 20 MBs to store the data. Now if I somehow compressed it and made it to a 10 MB compressed file, that means I am able to store the, I'm able to save the capacity, I'm able to save the storage capacity of my system, right? So this is the very first and foremost benefit of compression. Now, second benefit, second benefit, if I come here, is it speeds up the file transfer. Of course, a very major problem, right? Of course, a very major problem. It takes time, a lot of time to transfer the files from one object to, from one system to another system, from one platform to another platform. If we have a compressed file, of course it is going to take a less storage as compared to the original file. And if we'll transfer that compressed file, of course it is going to take a very less amount of time as compared to the original file, right? So definitely this is a very major advantage too, for those people who usually deal with the data transfer on the daily basis, correct? And it decreases the cost for storage hardware. Of course, that is very much relatable to the first point, storage hardware. I mean that external storage devices that I use to store the data. So that will, the compression will also lead to the reduction in those external storage devices, right? And Yeah, we can continue that. Decreases the cost for storage hardware and network bandwidth. Right, very much similar again. Network bandwidth cost is also reduced due to the compression of files. So again, this is a very important thing. This is a very useful thing to compress the data into some smaller capacity file and just store it like that only, so that we can we can take, we can use these much advantages of this particular thing called compression, right? Again, this is a very good thing to do, and we somehow realize that yes, comparison is a very useful thing. But of course, I told you in the very beginning that lossless conversion is the thing which is most, I would say, most preferred, because no one wants to lose their data. Okay. And what how we can figure it out that the conversion was lossless or lossy? When I'll restore, when I'll restore that compressed file, so I should get the data in the original form. Okay, I should get the file data in the original form. If I'm not going to get the data in the, if the data is not restorable to the original form, that means I had a lossy conversion. Okay. And I would say ki, well, when file information loss is acceptable, right, when file information loss is acceptable, it is used to compress only in that cases. Okay, the lossy compression is used when the file information loss is acceptable, of course. So we have to be very much sure about that only. Okay. Now, I guess this was a very good introduction about compression, its usage, its advantage, and how we have to make sure that we are going to get a lossless conversion. Of course, how we're going to do that, we will discuss in the further sections. But of course, this is a major highlight that yeah, we need to be sure about the lossless conversion. Correct. Yeah. So I guess that is much. That is a pretty good discussion about compression and its advantages and a lot of things. Now let's discuss about decompression too. Of course, you guys must have got an idea that what will, what should be the meaning of decompression, right? So yeah, let's have a quick discussion around decompressor or decompression. Decompressor is basically the process of restoring the compressed data to the original form. Okay. The process of restoring the compressed data to the original form is known as decompression. Decompression, and the process of doing this and the platform and the device and the software which is used to do that is known as decompressor. Okay. Data decompression is required in every case, I would say, uh, because I would say that in order to use that compressed file, if you want to use that compressed file, you have to decompress it first. Okay, you have to convert it back to the original form first, and then you can, and then only you can use it, right? So decompression is basically indeed a very useful thing, or it is a mandatory thing. Okay, to be used in every case. Okay, to be used in every case, right? So that is a brief intro about decompressor, and again, it has different algorithms, it works around different algorithms, and we're going to build one of those algorithms to make this compressor and decompressor successful. All right, so I hope you got an idea about what do we mean by decompression, what do we mean by compression, and how a compressor and decompressor gonna work like. Okay, what are the basic functionality which we're gonna have in the compressor and decompressor project for this particular session. Okay, so yeah, that's it about the introduction. Let's have a quick walk around of how the project looks like. This is going to be a very basic UI, a very basic UI window for our compressor decompressor. Select file to compress, select file to decompress. These are the two buttons which you're gonna have. Okay, I can click on this and I can select any of the files from my machine. Okay, I can select any of the files from my machine, and they will eventually, you know, compress or decompress the files accordingly. Okay, so let me quickly do one thing. Let me quickly select anything. I'm choosing something randomly so that you know. Again, application don't have nothing. Okay, let's try this. 2137257 JPEG. Okay, we compressed it. I guess compression should be done. Let's try to go back to that again, and let's see if we have any file saved for today. Okay, you can see this compressed 1.gz 5 March 2023 1:45 p.m. and you can see this is for today's date. So we got a compressed file here. Okay, now let's quickly decompress it. This was the file, right? Compressed 1.gz. Okay, let's decompress it again back and we'll have it here. Okay, compressed 1.gz was here. I guess yes, this is the file. Let me quickly check its properties. What I'm doing, I'm trying to show it to you guys that it is the today's file. Okay, the file which we decompress it is for today. You can see decompress file one, right? And we opened that, so we got back our image which we compressed to compressed1.gz, and when we decompressed it, was stored as it was stored with the name decompress file one. Okay, and it got saved, and when we are trying to run it, it is giving me back. This was the original image, and if I'm trying to run the decompressed file, it is giving me back the original image again. All right, let me put them one side by side so that you can see that there is no lossy conversion, there is no loss while compressing and again decompressing it back to the original form. So it all looks almost similar, so we can do the decompression of the images, compression of the images, text files, and all a lot of things. Okay, so this is how a project looks like. Very basic simple UI, and yeah, it has two buttons. And of course you guys are after watching the minor project one, you guys are very much familiar with how to build the UI. So we are going to definitely focus on the functionality, that how we're going to build it. Okay, now uh, let me have a quick discussion around this GZ extension. Okay, you guys must be wondering that this GZ extension is, and what how we're going to work around this. Okay, so GZ is basically, okay, GZ. Okay, this is a archived file. Okay, this is again archived file, because again if it is a compressed file, so it has to be, archived archive file. Okay, compressed by the standard compression algorithm. Okay, we're going to use gzip algorithm to to compress our files. So this gz extension files are created with the help of these standard compression algorithms, and uh, this is, I guess, enough for us to understand that how what this gz extension means. .gz. Okay, so yeah, this is a quick intro about this gz extension file, and of course we're going to discuss more in the upcoming videos. Okay, where we're going to build this project and we're going to use this gz uh, in our code. Okay, so we are going to have the introduction, or we're going to have the discussion around that also. Okay, so for the introduction purpose, it is, I guess, enough for us to understand that how the compressor and decompressor works like, and what this extension GZ means, and what all are the functionalities we're going to have in our project, right? So yeah, I hope you guys got a pretty good idea about this project. So that's it for the introduction video. Let's let's catch up in the next video, where we're going to start with the coding and the styling and a lot of things. So yeah, in this session we're going to have a quick discussion around two topics, that is technologies used for this project. By this project I mean, of course, compressor and decompressor, because you are watching this video inside this particular projects playlist. Right, what are the technologies, what are the things which we have used to build this compressor and decompressor, or which we're going to use, right? First of all, Java, definitely, because we are going to build this using Java language, and of course Java Swing. We're going to use Java Swing for all our designing part, for all all the things related to the graphics, related to the components, and related to everything which is related to particularly to the GUI that is going to be done through Java Swing. Okay. So let's have a quick discussion around these two things first, and then we will continue further. Specifically in Java, we're going to use a package named as java.io, java.io. Now, what is the use of this java.io package, and what is the general use, and then we will discuss how it's going to help us here in our project. Okay. Java.io package, or this io also means I/o, that means input output. Of course, we know it very well. Everyone knows it very well, right? So this java.io package provides a set of input streams and a set of output streams. Okay. It provides a set of input stream and output stream. Now, what are the uses of these input streams and output streams? Okay. These input streams and output streams are used to read, write data to the files. Okay. These input and output streams are used to read and write data to the files, or to the other input and or to the other input or output sources. Okay. Now, what is the need of java.io package here? First of all, we are very much clear with what do we mean by java.io package. It provides a set of input stream and output stream. And what are the uses of those input and output streams? These are used to read and write data inside the files. Okay. Now, if I talk about this particular concept here in my project, I need to give an input file to my project, to my software, and that input file will be compressed, and the output file and an output compressed file will be generated, and it will be given to me as an output. As I show you in the very first video, I was selecting a file. It was taking my project was taking it as an input, and it was generating an output file which was the compressed one, right? So this is the very basic use of java.io package in our project. And of course, this is a very mandatory thing to be used, because it is going to handle all the inputs and outputs of the files generated through our project. Correct. So of course, java.io package is very much necessary here. Okay. And we're going to discuss about input streams, output streams, and two more streams which we're gonna use in our project in the upcoming videos. Right here, we just gonna have a small discussion around the technologies. Now, inside the Java, I discussed the package java.io. I discussed what it is. I discussed what all feature it has. Now, in detail, we will discuss it in a separate video. Okay. Now, I hope we are very much clear with the Java wala thing. Okay. Now let's go to the Java swing. Okay, let's go to the Java swing. What is Java Swing? Let's have a quick discussion around this also. I hope everyone knows about it, right? Java Swing is is a part of it is a part of JFC, Java Foundation class. Okay, it is a part of JFC. Okay, Java Foundation class. And what is the use? What this Java Swing does? It is used to build the lightweight and platform independent window based application. Okay, lightweight window based applications. This is the basic use of Java Swing. We need this output window. We need this main window whenever we execute our code, whenever we execute our program. So to build this program, to build this main window, we need something which can help us doing that. So Java Swing has a major role in building this GUI application, this lightweight GUI application. And along with this, it also provides various components. Okay, it includes components like buttons, labels, texts, and a lot more things. Buttons, labels, labels, etc. Right. So this is the basic use. This is a very brief intro about Java Swing. You all guys, you everyone knows about Java Swing already. So that was just a quick intro about Java Swing. And in Java Swing, we're gonna use JFrame, which represents our main window. Okay, JFrame is the one which represents our main window. Whenever we execute the project, a window pops up. So that window is provided by JFrame specifically. Right. So this was a very quick uh, discussion around the technologies used in the project. Now, let me tell you one thing. On the click of a button, I am using this window gets popped up where I have to select a file, right? And on the select file to decompress, again this window pops up where I have to select a file. So how I'm able to do that, or what it is, or what how we implemented this in our project. Let's have a quick discussion around that also. The styling in our project is very simple. We're just going to have a window which is going to have two buttons which represent select file to compress, select file to decompress, and on the click of any of the button, I'm opening up a file chooser window through which I can select any of the file, and on the selection of any of the file and on the click of the save button, I can compress or decompress it according to the button which I have pressed. Right. So this is a very simple, very basic styling of our project. What you guys can improve, you guys can keep this button in the middle. You guys can provide a background image and a lot of more things. Okay. So I am just keeping a very simple, very basic UI, and this will be a kind of practice for you guys to improve the GUIs, so that it will become a practice for you, so that you will be able to do it in the projects which you will do it by your own also. Hera. So building a GUI and building the learning the process of how to do it is a very important thing. So yeah, I'm just I'm just leaving it up to you guys. So definitely do whatever you feel like to make this an attractive GUI, and or a good more. You can pop up a heading saying compressor and decompressor project, or say compressor and decompressor software, and a lot more things. You guys can definitely do that. So yeah, leaving it up to you now. Now, now, how I am able to how I'm able to open up that window which is letting me select any of the files inside my system. I am doing it with the help of J file chooser. This J file chooser, as it is very much clear by its name, that it helps me to choose the file inside my system. So whatever you see after clicking this, the save heading, the save as box, this label, this drop down, these listing, these all buttons, I have not built any of them. I have not built any of them. I've just called this predefined thing J file chooser, and it all came by default because this J file chooser has been implemented like this only. Okay. This J file chooser has been implemented like this only. So I have not provided anything. I have not provided anything. On the click of this button, I have just called J file chooser, and that's what I have done. And whatever you see inside this is all in written, all pre-written inside J file chooser. So it saved a lot of efforts, a lot of my efforts. So definitely whenever you feel like that you can use a predefined function which will save your efforts, just go on, just do that. Okay, definitely these predefined things are here for our help only, and this project is going to be all about the predefined functions, the predefined classes, right? We're going to use them according to our requirement, and definitely through those things, through those predefined functions, we're going to save a lot of effort, we're going to save a lot of memory, and it will be executed very fast, of course, right? So it will be in a blink of seconds, as I've shown you guys in the very first video. It was in the blink of seconds. It was with a blink that the file was compressed or decompressed accordingly, right? So yeah, these are some of the benefits of the predefined functions, predefined classes. So definitely now the question is that how we gonna know about the predefined functions, or are we supposed to learn about them? No, it all depends upon your requirement. Okay, build a requirement, and according to that requirement, do the researches. Okay, and if you feel there is any predefined function after doing the research, if you feel this predefined function can help you out, just implement that. As simple as that, right? Very simple. Just implement that, use it, If you don't feel that this is gonna help, just don't use it, right? So this is the very basic idea of how to learn about predefined functions, predefined classes which are there for your help. Take care. You should have a requirement, and according to that requirement, do the research. Definitely, you will come across some things which can help you out, which are already there inside Java. Okay, so yeah, that was a quick overview about the styling, and that was again a quick overview about the technologies used. Okay, so yeah, thank you so much for watching. I'll see you in the next video, and we will discuss about the input output stream and those two things which are going to use to compress or decompress our files, right? In this session, we are going to majorly focus upon building the basic layout, the basic UI, which we're going to have for our compressor decompressor project. Secondly, we are going to discuss around file input stream, output stream, and the input streams which we're going to use to compress and decompress our files, uh, respectively, right? So this is going to be the major agenda of this particular session. So yeah, let's start coding out. Okay, welcome to our NetBeans. We'll click on this new project. We'll use Java application, of course, with Java with Maven. So we'll name of project compressor decompressor. Okay, this is going to be the name of our project. Let's click on finish. Here it has created, and here we have a package. It's a predefined package. Let's quickly create a new package. Just creating it for my own, my own convenience, right? So yeah, if you don't want to, then it's all up to you. Let's add a new class app frame inside our GUI application, inside our GUI package. Sorry. So yeah, we have quickly created a project compressor decompressor. We have added a package GUI, and it has a appframe.java. And inside this appframe.java, we're gonna start building the basic layout, basic UI for our project. Okay. So of course, I told you in the very, I guess in the last video, that we're gonna use JFrame for all our for JFrame as our main window, and in the JFrame we're gonna put our components. Okay, and of course we are gonna have two buttons. So I need an action listener which will detect that which particular button was pressed, and according to that button which was pressed, uh, we need to implement certain functionalities, right? We need to implement certain functionalities. So yeah, this is going to be our main motive. Okay, frame is not abstract and does not override method. Okay, so we will of course override that also. Okay, not an issue. Okay, we'll do that. So let's quickly create these two buttons. I hope you guys are very much clear with why we extended JFrame and why we implemented action listener. If not, let's have a quick discussion around them also. Okay, in order to make sure that everyone is at the same page. I'm just trying to create two buttons: compress button, J button compress button, and J button decompress button. Okay, I've declared two buttons. Add import. Okay, let's do that. I hope the errors will fade away now. These are just simple warnings. Of course, you will use that. Now let's quickly do that so that this error will fade away. Our frame is not and does not override except method action performed. In action listen. Okay, action listen we're going to implement in the next videos. Of course, that will also work fine. Okay, let me quickly write it over here so that this error will fade away for you guys. Okay, public void action performed. Okay, action performed, and we're going to pass a param action event. Now everything seems fine. Action event. Let's add an import for action event. What I did here, I just overridden this action listener, and inside this I'm gonna add the actions which I need it to perform on the click of the compress button and decompress button respectively. Okay, that's what I have done. The main motive, the main agenda of this video is about this section only, and whatever we're gonna write inside this app frame constructor. Okay, so yeah, we're gonna discuss this much thing only right now. Okay, so what I've done here is I've extended the JFrame class. Okay, why I've extended the JFrame class? Why I extended the JFrame class? The JFrame class, which is already created, I want some functionalities. I want to add its implementation according to my project. Okay, I want to add the implementation according to my project. So what wherever this JFrame is written, I have extended it. Okay, I've overridden it. I uh, I have extended it and I am using it inside my project, inside this my app frame, and accordingly I'll be able to use all those functions that are written inside this JFrame, and I'm gonna give the I would say I'm gonna give the requirements, I'm gonna give the specifications according to my project, according to my needs only, right? So this is why I've extended this JFrame here. I've implemented action listener because, of course, this action listener is needed. Why needed? Because on the click of any button, I want someone to track that that particular button was actually clicked. Okay, let's say I click compress button, so I want someone to detect, right, that this compress button was clicked. So we need to perform the further actions on the click of that button. So this action listen is going to do that only. Okay, it's going to listen the action which I'm going to do inside that JFrame. Okay, so yeah, the very basic understanding of this particular line, I guess I've cleared it everything out right till now. Okay, so yeah, let's move forward. Let's move forward. If you guys have any doubt, just we can discuss that too later. Okay, so we will do this dots. We're gonna do some basic things which we did in the previous project also. Set default close operation. I want to close the operation, I want to close the execution on something. So this will be on jframe jframe dot exit on close. Okay, so I want it to get executed on the click of the close button. Okay, very much simple. And yeah, I guess that is enough. Okay, we use the compress button. We say compress button equals to new j button. We're declaring this, we're declaring the functionality here. Why we have to make it and as a new j button? Because with the help of this we get to write whatever this text has to whatever, however, well, in whatever way this text will be represented in the jframe, we can write that here. Okay, of course we could have written it over here also, like here j button compress button equals to new j button and select file to compress or something. But yeah, it's all up to you. You can do whatever you feel like. Okay, select file to compress. So I have initialized it. Otherwise, it would have given me an error that this is a null button. Okay, and let's do for the same for decompress button equals to new j button. Select file to decompress. Great, looks good, looks good. Okay, and yeah, on the click of these buttons, I want the action listeners to be added. Okay, so I guess let's do it in the upcoming video. Let's not do everything here only, otherwise it will be confusing for you guys. Okay, let's set the bound of these buttons inside my JFrame. Okay, so set bounds. Let's quickly give the boundaries. Okay, according whatever you feel like, wherever you want to set these buttons, you can do that. Okay, I'm just randomly type giving the boundaries to these buttons. Okay, 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 okay. Hmm. Set bounds. Okay, so yeah, I've set I have set the boundaries of these buttons. I have given the text which these buttons will represent. Now I just need to do one thing. I need to add these buttons. That's it, right? I'll add this dot add compress button. This dot add decompress button. Okay, I've added both the buttons. I'll set the size of the JFrame which I want to open up. Let's say 1500. I guess that will be enough. Of course we can change the width and height later also. Okay. And I wanted to set the background color also, so I'll do it like this dot get content pane. Okay, this dot get content pane return the content pane object for this frame, right? And that's what I want. Okay. And when I get the object, I'll set the background color of the object as color dot red. It is giving me a suggestion, color dot red. I can change the color also, color dot green or something, whatever I want to make the background color as. Okay. And of course we'll set the visibility of this keyframe as true, because we want to see that keyframe how it looks like. Okay, now let's quickly do one thing also. Let's make a main.java. Why? Because I want this to be executed inside this main.java. Okay, so that will do later. Okay, so yeah, a quick overview. This GUI package has two classes, appframe.java, main.java, and inside this main.java I'll call this appframe class. Okay, just this I want to do in this way only. Okay, nothing specific or nothing uh, specific for this project. Okay, as simple as that. Okay, so I extended the JFrame, I implemented the action listener, I created two buttons, I gave the text which these buttons should represent in the UI. For the compress button, I said select file to compress. For the decompress button, I said select file to decompress. I set the boundaries for both the buttons. I've added both the buttons inside the JFrame. I have set the size of the JFrame. I have set the background color as content as color dot green. I set the visibility of the JFrame as true because we want to see that JFrame, of course. Okay. So yeah, that's what I have done so far. And this is how we have implemented the layout. This is how we added two buttons in the JFrame in the layout. And how it will look like, we'll see in the next video, of course. Okay. So that was all about the buttons. Now let's quickly come to the second part of this video, a quick discussion around file input streams, output streams, and all those things. Okay. So yeah, we're gonna first discuss about file output stream, what it does. Okay. It this is a class. This class, okay, this class contains input bytes. Input bytes from a file. Whatever file I choose, with the help of this file input stream, I can obtain the input bytes from that file. I can obtain the input bytes which are written inside that file. Okay. It is also used for reading the byte oriented data. Okay. Byte oriented data can be image. Okay. Let me write it here for you guys. Used for reading byte oriented data. Okay, now byte oriented data can be image. Okay, it can be images, it can be data, it can be video, audio, etc. Okay. Okay, so this file input stream, it is basically helping us to read the byte oriented data. And with after reading that byte oriented data, I'll implement some actions which will help me in compressing those bytes which are written inside that file. And I've like read those bytes with the help of file input stream. So this is a very basic use of file input stream. I hope you got a bit of the idea about how this file input stream is basically gonna help us. Okay, we're gonna we're gonna read, we're gonna get the input bytes from a file. We're gonna fetch the input bytes from the file with the help of file input stream. Okay. I hope you got a pretty good idea about that. Now let's discuss about file output stream. What this is gonna do is it's gonna write the data. Okay, it's gonna write the data inside inside a file. Okay, that data will contain, that data will be the raw bytes. Okay, of course that data will be in the form of raw bytes. The data will be in the form of raw bytes, so it will help us in writing those raw bytes inside a file, or and it will also help us in storing that file also. First it will write those raw bytes inside a file, or it will store that file also. Okay, so it will be basically used for writing the bytes and storing data to a file. Okay, storing data to a file. So file output stream is basically helping us out for writing the data of raw bytes to a file or storing the data to the file. Okay, now how it is useful. Let's say I got a file, with the help of file input stream. I've read the bytes of the files. Now I've changed the bytes, and I want it to be I want it to be I want those bytes to be written inside the file, and I want to store those bytes inside a file, and I want it as an output file, right? I want to generate an output file for the same, and I want that output file to contain these raw bytes, right? So that will be handled by file output stream. Okay, because it is an output stream. Okay, it is an output stream. It does write the bytes, and it basically stores the data inside the files, right? So this is all about file output stream. File input stream, fetching the data. File output stream, writing the data, giving back the data, giving out the data. Okay, outstreaming the data. Okay, so these are the basic uses of these two predefined classes: file input stream, file output stream. Okay, I hope this is just uh, through this video, I just want to you guys to be familiar with this file input stream and output stream, so that when I use it in my code, you guys already know that what it is, and how we will implement that. Of course, we will see in the coding part. We'll see this in the coding part, of course. Okay. So yeah, just wanted to give you guys a basic idea. Now let's discuss about two important things related to the input output streams. This is gzip output stream, and similarly we have gzip input stream. Okay, first let's discuss about gzip output stream. Okay, it this class this class is useful. This gzip output stream class is useful for writing compressed data, for writing compressed data in gzip file format. Okay, we discussed gzip, so that is a gzip file format. So if we want to write the compressed data, okay, if we want to write the compressed data in gzip file format, okay, if we want to do that, so we use this gzip output stream. Now let's connect the dots. Okay, let's connect the dots. What is happening? I got the file, I got the input bytes with the help of file input stream. I decompressed it. Okay, I decompressed it, or I compressed it, not decompressed. I compressed those bytes. I compressed those bytes, and those compressed bytes are written inside the output file with the help of gzip output stream. Gzip output stream. That's it. Simple. Okay, we got the file input stream, we got stored the bytes, we compressed the bytes, and we have written the output bytes in the gzip with the help of gzip output stream, and this is the process is done. Right, simple. This is how it is done, and this is how this gzip output stream is gonna help us in doing that. Okay, for writing the data, we're gonna use the write function inside the out, which is there in the gzip output stream, and for reading the data, we're gonna use the read function, of course. Okay. So yeah, this is again a quick discussion around gzip output stream. Now let's discuss the gzip input stream. It will be relatable to you that now. Okay, gzip input stream. Again, gzip input stream help us to decompress it. It help us to decompress the files that are compressed with decompress the files that are compressed with the gzip compression algorithms. Okay. So specifically, if a file is compressed with gzip compression algorithms, we can decompress that file back to the original file with the help of gzip input stream. Now, how it's gonna happen? The gzip input stream is gonna read those compressed bytes. Okay, it's gonna read those compressed bytes. It is gonna decompression gonna happen, and we're gonna give the output file back with the help of file output stream, because of now the data is converted back to the original bytes, not the compressed bytes. Now the bytes are not compressed, so we don't need gzip output stream now, so we can use file output stream, a normal file output stream, and it is all done. It is all done. Simple. That is how the compression and decompression is gonna take place. Okay. So I hope I have cleared everything related to this project. Theoretically, in the next video we will code it out everything. Okay, whatever we have discussed, we have uh, we have created a basic layout also. So yeah, we have done quite a good progress. Now we will continue in the upcoming videos, and we will write down the logic. We will integrate everything, and we will see how our project looks like and if it is working fine or not. Okay. In this session, we are going to discuss the business logic of compression and decompression. Compression and decompression. We're not going to discuss it, we're going to actually code it out. And while coding it out, we will discuss whatever we are doing. Okay. I hope you all have a basic idea of how compression and decompression is going to take place, and how it actually takes place. We have discussed it theoretically. Now here in this video we're going to code out everything which we have discussed so far. Okay, so yeah, indeed it is going to be a very important video, so be attentive. Okay, be attentive and try to understand everything which I'm trying to explain. Okay, so for writing those comp decomp, let's make a new package, comp decomp. Okay, and inside these packages let's make new classes. First will be compressor, and the second one will be decompressor. Okay, so inside this comp underscore decomp, we're gonna have compressor.java and decompressor.java, and in these two classes we're gonna write our compressor and decompressor logic respectively. Okay, so definitely we're gonna write something here. We're gonna declare functions, we're gonna execute those functions. Let's see how it works. Okay, let's create one function. Okay, public static void method. The name of the function is method, and it accepts a param that is a file type. Okay, that is a file type. It will accept a param that is of file type. That means it needs a file whenever this function is called. Rows, let's say input output exceptions, because of course we are dealing with this. Okay, and yeah, let's add import for this also. Okay, let's create a main function quickly. Public static void main. Okay, public static void main. Let's make a path object and let's call this function method with param path. Okay, so it basically needs the path of the file as a param, and yeah, using this it will do something. Okay. Okay, I forgot to add that input output exception clause. That's why it gave me an error, and indeed it is fine. Take care. Okay. Now let's start this. Before starting this, I just want to make sure that wherever in the front end I'm choosing the file, uh, you know very well that I'm going to implement a file chooser which will help me in choosing the file from anywhere in my system. Okay. And I want my output file to be saved in that same folder only. Okay. So for that, I need the parent of that directory. I'm creating a variable file directory. Okay, I misspelled it, which will do what? File dot get parent. Okay. This get parent, what does it returns the path name string of this abstract path's name parent. Path name's parent or null if this path name doesn't have a parent directory. Okay. What is it actually gonna do? I'll explain you with the help of an example. Okay. Slash users. Let me give some address of any file downloads. Okay, and DOW and LOEDS downloads. Okay, in downloads I have a compressor. Inside this compressor I have compressor decompressor. Okay, compressor decompressor, and inside this I have a test file. Okay, so what this get parent gonna do is it is gonna return me the path up to this. It's gonna return the path of this test file of the parent of this test file document or whatever is this text file is. Okay, so what is who is the parent of this test file? The parent is this compressor decompressor folder. Okay, so it's going to return me the whole path up to here. Okay, and after this, inside this compressor decompressor folder I can put my compressed file. Okay, so in order to store the compressed or decompressed file in the same directory, I have to make sure that I get the parent of the I get the parent of the input file. Whatever is the input file, I get the parent of that input file, and inside that parent I'll push my output file, whatever is my output file. Okay, so this is how it's going to look, this is how it's going to work, and yeah, this is how we're going to continue, further. Okay, I hope this is very much clear to you guys. Okay, so I told you that I'll use file input stream to read the bits of the input file. Okay, so file input stream FIS equals to new file input stream. And what is my input file? My input file is file. Okay, let's add the import of this. Now it is fine. Okay, and of course my file output stream is FOS equals to new file output stream. Okay, new file output stream. Let me add the import statement for this. And this file output stream will contain what? It will contain this file directory. Okay, because we are going to push the output file in this file directory only. Okay, inside this file directory only. And now comes the role of gzip output stream, because we want our output as compressed file. Let me create an object for this. We want the output file to be compressed, so I'll use gzip output stream, and here I'll pass this FOS. Why? Because this FOS is basically the file output stream, and whatever bytes I'm going to write in my output file, I want those bytes to be compressed. So that's why I'm using gzip output stream. I'm using the gzip output stream. Now here I missed something, that I told you that after the file directory, after giving the whole file directory, after giving the parent path, I can give whatever I want to be the name of my output file. Okay, let's say here I want my output file to be named as compressed file dot gz. So this compressed file will, of course, be the name, and gz will be the extension, and this gz extension is compatible with this gzip output stream, the algorithm which I'm going to use to do the compression. Okay, so now I hope you got an idea about this file directory. It will take the path up to this compressor decompressor, and after that it will append this slash compressed file dot gz. Okay, so yeah, it is going to look absolutely perfect. Okay, so I told you one thing in the very starting, that the file is the combination of the bits, and the file input stream is going to read the input bytes which are present in the file. Okay. So of course, if I need to read something of byte type, so of course I need to make an array. Okay, an array of byte data type, and of course I need to give the size. Let's keep the size for is let's keep the size of the array as 1024 now, so it can read up to 1024 bytes. Okay, so with the help of this buffer byte array, I'm going to read the data, and then I'm going to write it inside my output file, which is gzip. Okay, which is gzip. Of course, my final output file is gzip, where I'm going to write the data, or I'm going to write the compressed data. So this gzip output stream, this gzip object will help me in writing the compressed data, and this fys will help me in reading the data, and this gzip will help me in writing out the compressed data. Okay, so this is how it's going to look like. Let's declare a length variable also. So I'll write while len equals to fis dot read. Okay, fis dot read, where I want this file to be readed. Okay, where I want this file to be readed, I want this file to be readed inside this buffer byte array, because that's why I have created this. Read it until or unless it is not equals to -1. That means until or unless you reach the end of the file, just read this. Just read this FIS file. Okay, just read this FIS file, and while len FIS dot read, what it's showing, incompatible type boolean cannot be converted to int. Okay, boolean cannot be converted into int. Okay, let's put the brackets here. Now I guess it will be fine. Yes, now it's fine. Okay. So first it will read the buffer up to the length is not up to it reaches the end of the file, and whatever will be the length at that moment, I'll store it inside this length variable. This is how this statement is going to look like. It will read the FIS file inside this buffer array up until or unless it reaches the end of the file, and it will store that particular value inside the length. So I'll get the total value of my input file FIS inside this length variable. Okay, so this is how it's going to look like. I hope I am clear with what I mean by FIS dot read. Okay, FIS dot read. I want let's discuss here FIS dot read. What I want to happen here is, and I am giving my byte array here. Okay, I'm giving my array as a param here. Okay, in my 4 it is buffer. Okay, so I'm giving that as a param. So I want what it does here is, it reads up to b dot length, buffer dot length, bytes of data. Okay, bytes of data from the input stream. Okay, into an array of bytes. Okay, I told you that the file input stream is used for fetching up the bytes which are there in the input file. So I want to read those bytes, and I want them to be uh, I want them to be stored inside the array of bytes. Okay, array of bytes. Okay, I want them to be I want them to be streamed inside the array of bytes type. Okay, so this is why I'm using fis.read, and this is the functionality of fis.read. So I hope the functionality is clear. I wanted to explain the functionality, that why fis.read is used here and what it actually does. Okay, so we have now we have everything. The bytes of array are there inside uh, inside my buffer array. Okay, now I want those bytes to be written, to be stored in a compressed way inside my file output stream, which is gzip. So I will use gzip. Okay, not here, in the next line, gzip dot write. Okay, gzip dot write what I want. I'll give the params and I'll explain you. Okay, I'll give the params and I'll explain you. So I've given three params. Okay, and let me close those files which I have opened. Gzip dot close. I'll come to the explanation, of course. I'll come to the explanation. Gzip dot close. Fos dot close. Fos dot close. Okay. So this gzip dot write, let's discuss about that quickly. Okay. We have readed the input bytes, and these are stored inside my buffer array. Okay. And now I want to write those bytes. Okay. Gzip dot write, and I have given three params. First is the bytes array, second is the zero, third is the len. Okay. So of course this is the data. Okay, this is the data. This bytes array, this buffer array is representing my data. Okay, this zero means offset length. Okay, offset value, offset value, offset length. Okay, it means the start offset in the data from where I should start writing. Okay, from where I should start writing. So I want the whole file to be written. I don't want anything to lose. Okay, I don't want to lose anything. So I want it to start writing from the very first character, from the very first byte, not character, from the very first byte. And this is the length, means the number of bytes I should write, number of bytes to write. Okay. So of course I don't want to miss anything. So I told it to start from the very first byte, and I told it to end at the at the last byte. Okay, so I should give the range as 0 to whatever is the maximum length of the byte array. Okay, whatever is the length of the file input stream. Okay, so that's why I've given the two params. First is the starting. Let's consider them as the starting index and ending index. Okay, starting index is 0, ending index is the length of the file. So of course it will cover the whole file. It will not miss any of the bytes. Okay, so these are the params which this write function needs, of course. And write functions helps you what? It helps you to write down the len bytes from the buffer array. Okay, starting with an offset value to the output stream. Okay, I want to write this buffer array with the starting offset value and with the ending value inside the from this buffer array to the output stream, and that output stream is of gzip type. So of course the output stream will be compressed one. Take output stream will be a compressed one. So that's why I have used this gzip object here, so that the output file will be a compressed one, and it will write the whole array of bytes starting from the uh, zeroth value to the zeroth byte to the to the last byte which that file will have. Okay. So yeah, this is how the compressed file looks, and I hope everyone got a good amount of idea that how this compression is taking place. Let's discuss it quickly. What will happen? This main function will get executed. It will call this. It will create a file path, and it will give. I've given this address manually. I've given this hard coded address. But in case when we will select a file from front end, so of course this will not get executed, right? This will not get executed directly. The method function will get executed, and it will have that address with it. Okay. it will get the parent of the file, so that after the parent, it can store the output file in the same folder. Okay, and the name will be the same, of course. Okay. Compressed file, compressed input stream, it will read the bytes of the array. It will help me in reading the bytes of the array. It will help me in writing the bytes of the array, and this gzip will ensure that those output stream, that output stream is the compressed one. This array, byte array, I am taking to read those bytes. With the help of this buffer array, I'll read those bytes inside this buffer array. Okay, this is the length, representing the length of the file input stream. Okay, I'm running a loop to read the file up to it reaches the end of the file, and I want it to write inside the gzip output stream. What I want to write, I want to write the buffer array which contains the bytes, and starting the offset value is 0 and the maximum value is len, and I'm in the last, I'm closing those streams. The gzip stream which I've opened here, the output stream, file output stream, and file input stream. Of course, this is the very basic thing, that we should close all those streams which we have opened and which we have used in our code, right? So this is a mandatory thing to be done. Okay, so this is how the compressor looks like. Now let's quickly make decompressor. Let's quickly make decompressor. It will be very much similar to what we have done in compression and compression, but of course a bit opposite, because this is how the functionality looks like. Okay, let's make this static also. Public static void method file throws IO exception. Okay, let's quickly add the import statements. Okay, here also we will do file directory. Let's do file dot get parent. Okay. Now here, let me remind you that the input file which we are getting in the decompressor.java, it is a compressed file. Okay, it is a compressed file. So of course we have to decompress it first. Okay, not decompress it first. Decompression is the basic functionality of this decompressor.java, but we have to read those bytes, because we have to read those compressed bytes. So we have to make sure that we read it in such a way that we can, well, we have to make sure that those compressed bytes are read properly. So of course we cannot use file input stream here because the bytes are compressed. Okay, file input stream, here file will be passed. Okay, but those bytes are compressed, so we will use gzip input. Okay, let me write it. Gzip input stream. Okay, we'll make gzip and I'll pass FIS, so that it will make sure that those compressed bytes are read properly. Those compressed bytes are read properly. Okay, and of course the output file, the output stream is going to look like a normal file. So of course we can use file output stream here. New file, output stream, file directory, plus decompressed file. Okay, yeah, I guess it looks fine to me. Okay, what we are going to do, we are going to get the file in the file input stream, and of course the bytes are compressed, so I'll pass it through the gzip input stream, and whatever bytes we get after in the gzip input stream, I'll decompress them, and I'll write them back to the file output stream. Okay, so this is how it's going to look like. Of course, very much similar to what we have done, exactly opposite of what we have done in compressor. Okay, The size will be 1024. Okay. Int len. Okay. Int len. Now let's uh, call the function. Sorry, let's deploy a for loop while len equals to gzip dot read, because we are reading the compressed bytes, and I want them to be readed inside the buffer array, and I want it to go till the end of the file. Okay. I want those compressed bytes to be written inside the buffer array with zero offset value and up to till the length of the up till the length of the file. Okay, and I want them to be written inside this FOS file output stream, so that it comes back as a normal it comes back as a normal bytes. Okay, so that the bytes will be normal, the file bytes will be decompressed and it will be written inside this FOS file output stream. Okay, gzip dot close, FOS dot close, FIS dot close. Okay, gzip dot close, FOS dot close, FIS dot close. I guess everything is done inside this um, decompressor 2. Let's make the main function also public static void main string file path equals to new file. Let's say I have this compressed file in this particular. Okay, I have this compressed file, not this one, of course. I'll change the name here. After comparison, this file will be created, and I'll give the address of this file here. Simple. Okay, I'll give the address of this file here, compressed file dot gz. Okay, so I've given the address of the compressed file, and this will be decompressed, and this will be stored as compressed file dot gz. Okay, 1 second. I've done. Okay. Hmm. I guess now it is better. It will pick up this compressed file dot gz as input part and will give me decompressed file as an output file. Okay. So yeah, this is how the decompressor looks like. Of course, let's repeat again. I'll read it with the help of file input stream, but again the bytes are decompressed. So of course I'll read them with the help of gzip input stream. Okay, and I'll write those bytes after decompressing into the file output stream FOS. So I'm reading those compressed bytes. Those compressed bytes, I'm writing them down after while reading the bytes will be decompressed, and I'll write them down to the normal file output stream, to the normal uh, stream, right? I'll write those bytes down to the normal streams. Of course, they will be decompressed, and I'm closing those files here. Okay, I'm closing those files. So I hope this compressor and decompressor.java, both the classes are very much clear to you. In the next video, we will do what? We will discuss the action listener, and then we will call the function. That's it. That's it. The project will be done. This is going to be the last session for this particular project, compressor and decompressor. We have almost done everything. We are done with the designing of the layout, designing of the UI, a very basic simple UI, and we have written the business logics for the compression functionality and for the decompression functionality too. Okay, so we are left with one thing, that is the implementation of action listener. Okay, that is implementation of action listener. So we are going to cover this in this particular video, and we are also going to finish the project after implementing the action listener, and we are going to dry run how this particular project, how this particular software, how this particular application works like. Okay, how this looks like, how this works like, is it working fine, is it according to our expectations or not. We'll figure out everything in this particular video, and we will conclude the project, and we will end it in this particular video only. Okay, so first of all, the action listener is basically an interface action listener. Okay, how we got to know that? Because we are using implements here. Okay, we are using implements here. Interfaces are the ones which are generally defined but are not implemented. So for writing the implementation of action listener, you have to implement it first in your class, and then only you can, implement and give the functionalities, give the code lines according to your usage. Okay, so this is the basic meaning of action listener. It is basically an interface which we need to implement in our class, and there we can provide all the functionalities related to our project, due to which we are using the action listener. Okay, so what it does is it receives the action events. Whatever events are happening, it basically receives it, it basically listens to it, and it basically performs the action accordingly. Okay, performs the action accordingly. This is a very basic meaning of action listener which we have. Okay, so basically it is called just after the user performs an action. Of course, until or unless there is no action performed from the user side, of course we don't have to do anything. But as soon as the user performs any action, we want these functions, these this action listener to get executed. So of course it gets executed only then whenever there is a function done, when there is a action done by the user. And to handle that, we have an action performed function, which basically takes the action event as a the object of the action event as a param, and it basically allows us to what allows us to access the properties of action event. Okay, so the action performed, basically a method is called when the associated object generates an action, of course, and the action event carries the properties. If the action, it basically helps you identify that what should we do, right? This is the basic concern, that what should we do. We have identified the action. Okay, and we want some action to be performed. We want something in place of the action which is performed, so we have to identify that action, and accordingly we have to perform something, we have to deliver something accordingly, right? So this is a very basic idea of action listener, of how it works, no, of what is its usage. Now how it works, we will implement it definitely in our code, and we will see how it exactly works. Okay, so let's come to the coding part. We have an action performed function which is taking action event e as a param. Of course, that's what we discussed. Very simple. If e dot get source equal compress button, that means if we have pressed the compress button, if we have pressed the compress button, okay, so I'll on the click, we decided that we will show a file chooser. Okay, a file chooser which will help us in choosing any of the file from our system. Okay, from our system, from our machine, we want to choose any of the files, so we will use jfile chooser here. Okay, let's add the import statement for the jfile chooser. Of course, it comes under Java Swing. Okay, here it is. Seems sorted. We created an object for the file chooser, and of course, in for the response, we have to make sure that we show the save dialog box. Okay, so file chooser has a save dialog box. Dot show save dialog. Okay, it has a save dialog. Wait, let me give the proper declaration. Okay, so it pops up the save file chooser, chooser dialog, and note that the text happen that appears parent, the parent component of the dialog can be null. Of course, the parent component can be null. So what it does is it pops up the save file chooser dialog. Okay, Of course, we need we need it in our we need it in our project. That's why we have implemented it, and we are making sure if a response is equal only to the approved user dot approve. Okay, we have a lot of things. So I guess what this return value if approve, yes, okay is chosen. Okay, so I guess let's use this because it's of type int also. Okay, so if response equals jfile chooser dot approve option, then only we will implement the further things. Okay, I told you that we will get the selected file first. I told you, sorry, not I didn't tell you this. I told you that we will make sure that we are saving the file in the same directory from which we are choosing the file. Okay, so here I'll make sure that, of course, this main function I wrote it down to explain you that how the path is gonna get picked and how it's put how gonna extract the file directory, and then it's gonna append the file name in the file directory, and it's going to give the output file in the same folder. But here, of course, we will call the function directly, the method function. So of course we have to do everything here from our own. Okay, so what I want is, firstly I need to pick that file whatever is chosen. Okay, so I'll say file chooser dot get selected file. Whatever file I select, I just want to get that file, and I also want to get the absolute path. Okay, get the absolute path of that file. Okay, so yeah, we are getting that selected file, and we are also getting the absolute path of that file, and we are storing it in this file path. Of course, our function method function needs the path of the file, right? The whole path of the file. So it will definitely look something like this only. It will definitely look something like this only. Okay, so we have created successfully created the file path, sorry, file object. So let's try to print it also in the terminal, so you'll see that how it looks like. Okay, so now it will do what it will try. I hope you guys are clear with the try catch block. Okay, and now I want it to implement this comp decomp dot method, not the comp decomp. I'll choose compressor because it is written inside compressor class, right? I was writing the name of the package. Okay, so I want this compressor dot method function to be called here with file as param, and yeah, I want it. So add a catch. Of course, I'll add the catch. So for with try comes the catch block. Catch exception exception e. Let's handle the exception as e, and whatever exception comes up, we will show that exception. J option pane dot show message dialog. Okay, the parent component is going to be definitely null. E dot to string. Let's see what all errors we have. Replace with catch IO exception. Okay, it's giving me a suggestion to replace it with catch IO exception, but I don't think we need that. Okay, I have declared a general exception which will check everything up. Okay, so let's try to go as per the suggestion also. Let's see how it works. Okay, okay. The problem was with the variable e, right? I That's why I thought why it is giving me this error. Hmm. Because I'm declaring a general exception error. I'm not giving any specific exception. Let's say input output exception, null pointer exception. I'm not giving any specific exception. I'm taking it as a general exception. Okay, so it will catch every exception it gets. Okay, in the same way we're going to implement for e dot get source equal decompress button. If we get the decompress button, I'm sorry, We get the decompressed button as the source. Let's copy paste that out. Okay, we'll choose the J file chooser, and in the response we will do everything here. Now we just only need to change the decompressor. Start the import. Yeah, I guess the rest of the things are the same here. Okay, so almost everything is done. Everything is done here. I just need to create the main function inside this main class. Okay, inside this main class, and here I'll call this app frame. Okay, I'll call this app frame public static void main. I'll call this app frame class here. Okay, so we have called this app frame class here also, and we'll directly run this main.java. We'll execute this main.java, and I will get the output file, output window. Okay, the output JFrame. Okay, so we are almost done with everything. Now here I just need to change. Just need to add few statements. What are those statements? I need to implement those action listener, right? So on the click of compress button, I want to add what I want to add. I want to add the action listener. Okay, so of course that is also needed. We'll pass the current object, and same goes for the decompress button. I just want those. I What I'm doing here. Let me explain. I am adding the action listeners on these buttons. Of course, if I'll not add the action listeners on the click of those buttons, I'll not get the source. Like I'll not get the source. So if I want the sources, if I want to get the sources, of course, I need to add the action listeners on the both the buttons so that I can get the proper source that which particular button was pressed. If there is no one to listen the action which is performed on any of the buttons, of course, this will the whole process will get failed and will not be able to identify which button was actually pressed. So to get the sources, we are adding the action listeners on both the buttons. Okay, we're adding the action listeners on both the buttons, and I hope everything seems fine to me now. Let's run this and let's get the output file. I hope it will work absolutely fine. Okay, we are getting it. We are getting it. Somehow a bit distorted, but yes, we are getting everything. Let's see, select file to compress. See, it is showing us a save dialog box, right? Select file to compress. Let's select the file from here, not here. Downloads, compressor, decompressor. I want to compress a file, right? So let's see this test file. Let's compress this test file. Okay, I selected this test file. Okay, let's see if we have compressed anything. Okay. Have we done that? Yeah, see, compressed file.gz, compressed file.gz, Sunday 5 March 8:41 p.m. That is the time, today's time, right? So we have created a compressed file from this test file. So the test file was compressed to this compressed file.gz. Now I'll select this compressed file.gz and it will be converted back to the original file. Let's see. We had a test file. We compressed it to compressed file.gz and we decompressed it back to the decompressed file. Okay. So yeah, that is definitely a very good thing to do. Here, let me explain you one thing. In the test file, it has 22 bytes, and in the compressed file.gz, it has 42 bytes. So, of course, how this is possible? Of course, this is not possible. But here, what is happening? The test file doesn't contain anything. Okay, the test file doesn't contain anything. So, while compressing, you are actually not able to see the difference. Okay, if you will choose a file of a bigger memory of in MBs or something, you'll definitely see the compressed file to be of a smaller size as compared to the original file, of course, and that is the basic that is the basic functionality of this compressed project, of compressor decompressor project, right? So try with a file of a bigger size, let's say in MBs, and try to compress it, and definitely you'll see a lot of difference. It will save a lot of space, and try to decompress it back, and it will be of the original size again. Okay. So this compressor decompressor works absolutely fine, absolutely perfect. And yeah, I hope you enjoyed learning this minor project. It was very interesting, yet very, um, yet very I would say new to us, because we used definitely different aspects of Java here. We used a whole package of input output, and yeah, we played with the predefined functions very well, which helped us to save a lot of effort, save a lot of line of codes, and it made our project a very simple one. Indeed, yes. So yeah, I hope everything was clear to you guys. I hope you learned it and you enjoyed it as much as I did. So yeah, thank you so much for watching this series of this particular project. I'll see you in some another project, in some another learnings. Thank you so much. Bye bye. Take care.